Yes, let me start the recording again. So next, now we have seen, so there are four boundaries that we will mostly be seeing. So one was between Precambrian and Cambrian. Then after you move to Paleozoic. Next boundary you will see between Paleozoic and Mesozoic, which we call the uh, Permian-Triassic boundary. Then you move into Mesozoic. Then there you'll study the boundary between the Mesozoics and tertiary or the Paleogene period. It's known as Cretaceous Paleogene or Cretaceous Tertiary boundary is actually an older name. And then you move into Paleogene and a Neogene here, and then finally we'll go into Paleogene Neogene boundary. So these are the four main important boundaries which you have to study in boundary problems in India. We have already covered the Precambrian Cambrian one, and now we will come to the Permian-Triassic boundary. And I think you all know what is Permian-Triassic boundary famous for.
Gondwana.
Permian-Triassic boundary extinction, the mass extinction, the great dying.
That is
Yeah. So which is considered to be the biggest mass extinction which the Earth has faced, where like almost uh, most of the life forms died at end of this Permian-Triassic extinction event. So this Permian-Triassic boundary. So whatever whenever we define these boundaries, usually we have an international stratotype which is defined. So you defined it at a certain type location. So where the boundary is defined, then you date it. So it's usually defined where you observe some contrast, sudden change in biota, maybe some the type of animals that you get, they sort of change suddenly across a boundary. So you go there, you define a stratotype, you date that stratotype, what is the exact date, using let's say radiometric dating. And then once that stratotype is defined, you sort of try to find its equivalence across the globe. Okay, so that you don't have to always date it radiometrically. So once you define the boundary, let's say at the international stratotype, and for Permian Triassic boundary, that's at 251 million years ago. So once it's defined over there, you don't need to go everywhere and then carry out radiometric dating. Now the boundary is fixed in time at a 251 million years ago. But when we go to the field and then what you do basically is try to find equivalence of that boundary in different places. Now you may say, why don't we always radio date those boundaries, so you can always do radiometric dating and find the age. Radiometric dating is not straightforward technique, as you know. For example, when we studied uranium lead type of dating, or rubidium strontium, so or argon even. So there is a concept which we call uh, let's say closure temperature. Okay, they don't always in radiometric dating, you do not always record the age of the rocks. Okay, at what point the sediments were being deposited, there will always be some error in that. And basically what you are recording, okay, that also matters. So for sedimentary rocks, what will you do? Carbon dating will not work for these old rocks. So for igneous rocks, it's even easier. But for sedimentary rocks, it's not as easy. So the Permian-Triassic boundary is now defined as the point at which a specific species of fossil conodont and extinct, again these conodonts we have already studied in paleontology course. So at the stratotype at that location, so this fossil species it's a conodont called Hindodus parvus. Okay, first appears in a geological section at Mishan in South China. Okay, so it's this Conodont fossil, first appearance of this Conodont fossil, which is used to describe the Permian Triassic boundary. Okay, and then radiometric dating yields an age of 251 million years ago. So the appearance of this Conodont species Hindedus parvus is what is used to define the international Permian-Triassic boundary. This right here is again an example of the Permian-Triassic boundary from China. So it's not like you don't see anything spectacular happening. So this is known as a global boundary stratotype, and what you see here is there is this some volcanic ash bed, and the mass extinction starts at this point, so towards the end of the Permian. And when you go to the Permian age here, so once you cross this, so this is the actual boundary of Permian Triassic boundary in this age. And this extinction event or this volcanic ash has been dated at around 252.28 million years, and the boundary between Permian and Triassic is defined at 251 million years ago. So most of the time the boundaries that you will find, so they 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 will be just like here. You will see chunk of rocks, and in between you'll find the boundary. The boundaries will be conformable, or you will actually see the boundary only in areas where there was continued deposition, which were still submerged under sea. Okay, where they have undergone unconformity, so you may not see the actual boundary. So where the rocks were exposed, maybe they were exposed later on, and then this boundary may have been eroded. So this is the global boundary stratotype point for the Permian Triassic boundary. This is another example of Permian Triassic boundary. So it's not marked exactly where the boundary is, but you do see some contrast in the rocks. What do you notice in these rocks between when you go from Permian to Triassic? Any observations in terms of color?
Rocks are more grayish than
Yes.
Triassic.
So here you see these Permian rocks. They're more grayish than the Triassic rocks, and there's a reason for that. Triassic period, again, it was a time of when supercontinent Pangaea had assembled, and also Triassic is usually all across the world. It's very arid. Okay, Permian was a more humid time period. There are many things that you see in Triassic period, which you would know, so it's not seen Permian. So Permian was more humid than Triassic. So whenever you have arid environment, more terrestrial, there was more volcanic activity towards the end also. So there was more iron content and there was oxidation. So in general, the Triassic rocks you'll find they are sort of like reddish in color, and that is actually how this name Triassic also comes. So it is based. Triassic means three, so there are actually three main rock types which you will find all across Germany. So it was actually a German geologist who named the period Triassic based on these three types of rocks, and one of those rock types are these reddish rocks or red sandstones that you find within the Triassic period. So it was pretty arid during that time. It was not a humid environment, and you see these rocks. Another thing that you will observe in Triassic rocks, if you look closely in many areas, the Permian rocks, they're mostly you will see they are heavily bioturbated. Okay, so you will see a lot of bioturbation, these worms, and whenever you see bioturbation in rocks, so what these organisms which are living on soft sediments, what they do is, let's say rocks are deposited in these sediments are deposited in these layers, they're still soft. So these burrowing organisms, they will sort of like destroy these layers. They will move inside, they'll move sand out, or they'll churn the sediments. So you do not see very nice layers. But once you look at Triassic rocks, what you'll see is these layers are also preserved. You don't see evidences of bioturbation. You will see very nicely layered sands with very nice internal laminations, because at least towards the base of Triassic there are very few organisms which are remaining. Most of them go extinct as you go from. So you'll see a lot of biota here, and as you move to Triassic, you will not see many organisms in this. So and then you can do isotopic analysis and other things also. So the Permian ended with the most extensive extinction events recorded in paleontology. So the Permian Triassic extinction, nearly 95% of marine species became extinct, as well as 70% of land organisms. If you look at the figure for genera, I think it will be around 80%. So it is also the only known mass extinction of insects. So when arthropods also underwent mass extinction. Otherwise, the arthropods, they're very resilient, and they have gone extinct from time to time, but they have never suffered mass extinction after this Permian-Triassic mass extinction. Uh, Another thing that I want to say is usually, if you look at specimen level and let's say species level and genera level, and when you look at these extinction numbers, maybe you say this is 95% for species. For genera, I'm not exactly sure what the exact number is, but it's less than 95%. Let's say it's 80% of all the genera they went extinct. And if you look at specimen level, how many individuals actually died, this will be more than 99%. So these ratios usually decrease as you go higher up in the taxonomic levels. And then the reason is simple. Let's say uh, if genus A is divided into, let's say, 5 species, or it could be 10 also, and then genus B is again, let's say, divided into 5 species. So there are, let's say, over 10 species. Uh, let's say just one survived. Okay, this 10th one, all of these went extinct. 9 of these. So on species level, the extinction rate is 90%. What about general level? How many? What is the extinction rate on general level? Genus A went extinct, right? Genus B is still surviving. You still see that some members within genus B. So what is the extinction rate at genus level? And again, this is just an example. It's 50%, right? One of them went extinct, one of them did not go extinct. So usually, as you go higher up in these levels, you'll see that this value for extinction percentage usually decreases. If you go to family level, the number will be even less. So this is just an example to show you that the numbers will decrease as you go higher up in the levels. So again, these are some sub signatures that you see around this time. uh, and then you see that towards the end of Permian and then the base of Triassic, it's like when Pangaea had integrated during this time. At the Permian-Triassic boundary, you also see, just like we see Deccan traps in India, which are close to the KT boundary. This Permian-Triassic boundary, so you can see Siberian traps, which are again huge volcanic traps, flood basalts which were erupted, which erupted around this time near Permian and Triassic. So we'll not go to exact details of why extinction happened, because that is I've uploaded that in the paleontology course on mass extinction slide. And you see these again negative positive excursions in the carbon cycle around this time. So sometimes it go very low, sometimes it comes very high. And in oceans, you see this aragonite high magnesium by calcium ratios exactly around this time, and it's actually pretty for a long duration. And this usually indicates anoxia. That is, what do you mean by anoxia? You know, anoxia means your oceans becomes anoxic. So means there is no oxygen in the oceans. So oceans become oxygenless during this time. And you can see in biodiversity levels that during this stage, almost everything disappears. In biodiversity, you're talking about more than 99% of the specimen, they just do not survive this extinction event. Initially, you would have seen a lot of different kinds of organisms in the oceans. And 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 they were undergoing some extinctions in the previous extinction events, but it's during the Permian-Triassic extinction that many of them went extinct. Okay. And it was actually, the recovery was also pretty slow after this, but that this paved the way for emergence of reptiles in the Mesozoic period. Now, where do we find these boundaries in India? So the Permian-Triassic, the best example from India is in the this Guruyul ravine. So a ravine is just a small nala or a cut that you see in the area. So this is exposed in Kashmir Gurial ravine. So the fossil content of the lowermost Triassic rocks is markedly different from those of uppermost Permian rocks. So you have uppermost Permian rocks exposed there, and then also Triassic rocks. There is just one point I also wanted to discuss in here when you see this rocks in here. So if you are, let's say, looking for coal deposits, what type of environment will you prefer? So one when you're seeing Permian or when you are in Triassic?
Permian.
Permian, exactly.
Permian.
So that is why you see these coal deposits of Permian age or Carboniferous age. But once you go to Triassic age, you don't see any coal deposits also in that time. This was mostly an arid environment, and most of the land plants also died during this sediment during this stage. And even if you look at the type of geomorphic features in Triassic rocks, you find very few meandering rivers. A lot of streams also you'll find they are in they're sort of like having braided nature during this time, because what will happen when you have very little life on earth, there are very few plants to or on in continental environments. So erosion rates are also very high at the same time during the Triassic, because plants, their roots hold the soil together, they prevent erosion. So you saw a lot of sediment supply. Whenever you see a lot of sediment supply, it usually results in braided river systems. So it was a very different environment, especially at the start of Triassic. Let me show you where this Gurial ravine section is. So I was actually interested in this, seeing where exactly this is. So it's in Srinagar. So yes, so this is it's not in Srinagar. It's close to this. So this area that you see is the Kashmir Valley, and you can search that also. But these hills that you see right uh, east of Srinagar, it's actually one of these hills. So you can see these sort of nice exposures of these cuts in these rocks here. So this is all these layers that you see in here, they are all Permian in age. Okay, the beds that you see in here, these beds, are they younger or older than these beds? Can you see my cursor? Just want to ask.
Yes, sir.
Okay, so these, which one? Just based on principle of superposition. So now they are dipping also. So nothing is overturned in this case. So which one is older? Which one is younger? One are these, and another is on top. So here it will not let me draw. So these are dipping that way. So when you move in dip direction, you always go into younger and younger beds. So you're moving in dip direction, and this is where there's some quarrying of, you can see this is sort of a limestone quarry. So you definitely see limestones in this area. Somewhere above here also you see some limestones, and once you climb through these hills, it's again a satellite image, so you will not see most details. But this is the position where you find the Permian Triassic boundary in India, in Kashmir. So once you climb, let's say, the face of this hill, right here on top, you will see the boundary between Permian and Triassic rocks in India. Again, this is the Guril ravine area in Kashmir. I'll share this location course website also, because again many times you study these things in the Indian stratigraphy and all, they're actually very interesting. But once you just see text without any images or sort of understanding of where these are located, the physical nature of this, ideally the best way to do is to go to the field, look at the character of rocks, maybe some, if you can identify some fossils in there, and then that's always the best. But still you should try to sort of understand where you get these in here. So this again Gurial ravine section is where you find uh, the the Permian Triassic boundary. And extinction of, again, brachiophore fauna of productus shales is abrupt as appearance of and predominance of Triassic cephalopods. So again, Productus is Paleozoic Productus limestone. You'll see when we study the Paleozoic successions, it comes there, and these brachiopods, the Productus, in what you call the uh, of the brachiopod fauna of the Productus shales, it goes extinct during this time. Okay, so brachiopods, they are still surviving today, but there are very few species which are left. Brachiopods were much more abundant during the Paleozoic. Nowadays, only a few brachiopods survive, and that is why one of the specimen of brachiopods, it's known as the living fossil, which survived this extinction, and that is Lingula. So this is in Vihi district of Kashmir. It provides one of the best sections on where the Permian-Triassic boundary is defined both on faunal and lithological characteristics also in India. And broadly speaking, on top, if you observe this like rocks from top in this area, overall they sort of like become, you can see the character that you see here, these nice layers, and the character that you see in these areas, that also changes. These are the Triassic rocks, whereas the ones that you see underneath, they are Permian in age. They also appear slightly reddish in color compared to the rocks that you see of Permian age. Rest, they are surrounded by Panjal traps, so this exposure is not very extensive in here, but the exposure is there in other areas also around this part, but you don't really see the boundaries. So the Paleozoic rocks in India, they're not very common. So they're exposed in Himalayas. But if you go to, let's say, the peninsular India, or even the mainland, or not, I shouldn't say mainland, but the non-peninsular part, the extra-peninsular part, that is not the Himalayan part. So these exposures of Paleozoic rocks are not very common. So you in Spiti, they are exposed in Kashmir, Himalaya. You see Paleozoic rocks, but they are not very common in India. So this is Productus, which is a genus of, again, articulate brachiopods, characteristic of Carboniferous and Permian strata. They usually lack a pedicle, but they are often anchored by spines of shells, and sometimes these could be very very big. They could be huge, as big as like 1 foot. For example, Productus gignatius was almost a foot long. Then you will see, I'm just telling these examples of brachiopods because this is what you will find in the rocks over there. So then there are Otocerus and Ophicerus beds also, and these are not brachiopods, but they are uh, ammonites, ammonidae, but these are cephalopods actually. I shouldn't even say ammonites because ammonites, they have a specific type of suture. So Otocerus and Ophicerus, they are usually what we call of seriatite type sutures. So you remember seriatite looks something like this, the seriatite type of suture. So you see these seriatitic brachiopods on top of these rocks which are rich in brachiopod fossils or bearing productus. This is the actual section of the uh, boundary between Permian and Triassic. So these are different units within the Zevan formation, and on top of Zevan formation, you see this Permian Triassic boundary, and you go into the Mesozoic rocks of Kunamu formation beyond this part. And again, this boundary, people, because now you see, whenever you see transition, it will not always be very well marked. Okay, so different uh, uh, scientists, they have again defined it at slightly different locations, and then you can see in sometimes you'll see these black shales. uh, the base of black shales is sometimes considered to be the Permian Triassic boundary. Sometimes it's on top of the black shales which are observed. Again, these black shales are actually pretty common within the Permian period. So because of again more humid environment, more organic material, you will, and then you go to limestone cliffs, and then there is this lower Triassic, which is for example, Wadia defines it on top of the limestone cliffs, and what is shown in here is that these are limestones, and the faunal assemblages, how these species are changing within these uh, limestones near the boundary. Again, this is again you saw that limestone quarry over there. Again, different units and stratigraphy that you see within this area. Here I have just like we will go through these in detail when you study Paleozoic successions, but uh, all these purple limestones that you see, they are in Triassic age, and the Zivan limestone, again Zivan we studied that the age of Zivan limestone is Permian. Okay, so it's Paleozoic, and this is where you see this. We saw that right east of Kashmir. So you saw that sort of Permian-Triassic boundary. It's in this area. You see it south of Falgam also, and near Sonmark. Near Sonmark, you don't see the boundary. You only see those minerals. These no, not the Mesozoic, but the Zevan limestone, which is again Permian in age. Now, in Spiti, this boundary. So the best example is in the Gurial ravine section in Kashmir. You also see it in Spiti. So the Triassic succession begins with massive limestones, which are autocerous bed, overlain by flaggy limestone, which is ophicerous bed. Okay, so you have productus shales underneath. So productus again is Permian. On top, you have autocerous massive limestone bed. So these are Permian black shales. Okay. So again, you can see here they're named black shales, maybe due to weathering on top. You are not seeing, and above these you see these limestones which are cephalopod bearing, whereas the rocks underneath they are brachiopod bearing. So the shales here bear mostly productus, and then on top of these you see autocerous bed, and on top of autocerous bed what you call is this is the part which is called flaggy limestone. What do you mean by flaggy? You use this term, so it will have these sort of like layers. It will
Fissile,
appear. Yes.
uh, like showing fissile
Yeah,
character.
yeah, exactly. So it's looks a little bit fissile, so you'll see this sort of like this kind of character. So when you see the rocks, massive will be just no internal layering. So this is massive and this is flaggy. Okay, so it's not like very closely spaced. These layers are not very closely spaced when you call something flaggy. Okay, so they're slightly widely spaced, few centimeters apart, and underneath you have the massive sandstone, and underneath that you will have the black shales. Now we come to some of the Gondwana basins in India. So outside of the Himalayan region, so the PT boundary for continental sediments. So now we are not into marine sediments. It's for continental sediments. It was established for the first time in the Benpetalik Nala section of Gondwana basin of Raniganj, West Bengal, and this is based on occurrence of aestherids, which is a group of small crustaceans, and these three aestherid horizons have been identified within the Panchayat formation of Raniganj area, and the GSI proposed that the Nala section is the first continental stratotype of the Permian-Triassic boundary. And this is not the, so the limestones that we were seeing initially, they are more like the I would say marine these are marine examples of the boundary. So and on top you see their limestones, on bottom there their limestones. So exposure was not there, so you don't see an unconformity here. So it's always better to observe in areas where you don't see unconformity. But if even in continental setting there could have been continued sedimentation if there was a continental basin in the area, or intracontinental basin, or let's say you have a fluvial or braided system. Another thing is that this limestone, this section is not yet accepted by the uh, stratigraphic commission as actually representing the or the exactly where this Permian-Triassic boundary lies. So there's still a little confusion regarding that. So the macrofloral record of Gondwana sequence of India shows a major change towards the end of the Permian period, that is expressed by withdrawal of large number of leaf genera. So you see a lot many different kinds of these fossils from the Gondwana group underneath, which change as you move beyond the Permian rocks. So we move out of the Permian rocks. The spores and pollen have been regarded as the most reliable aid for dating Permian-Triassic boundary in the Gondwana sequence in India. Thus, the Permian-Triassic boundary within Gondwana sequence lies somewhere in the middle of the Panchayat formation. So this is about the Permian-Triassic boundary. Again, the best example is in the Gurial ravine in Kashmir.